Hello, in this video I'm going to look at an application of graphs of trigonometric functions. So we're going to look at a problem, a word problem. The alternating voltage E in an electrical circuit is given by E equals 110 sine of 120 pi t, where t is time in seconds. Now, they ask you several questions here. What are the amplitude and period of the function? What's the frequency of the function? And to graph the function on the interval between 0 and 3 over 60. Now, first, when you look at this, sometimes you might think, well, gosh, I don't know anything about electricity. How am I supposed to even do this? Well, they tell you that E is the voltage and T is the time in seconds. So the first thing you want to do is look at what two things are changing. What are the two variables? So we know that because E depends on T and T is time. So essentially I know this is one variable, this is the other variable. And we can see that E depends, the voltage depends on time. So E is the output, T is the input. Okay. Now luckily they give us the function, which is kind of nice. All right, so once we have that, let's start looking at some of the questions they're asking. What are the amplitude and period? So now the amplitude is given by the absolute value of A. So here's A, B, let's see, and B is all of 120 pi, right? And really you don't have C or K. So if we write this a little differently, we could write it this way. 110 sine of 120 pi t, you know, minus 0 or plus 0 really doesn't matter, plus 0, right? So there's your A, B, C, and K. And now remember, C is 120 pi. It's everything that's the coefficient for the input variable t, okay? All right, so now let's take a look at A. What's the amplitude? So absolute value of 110 is still 110, so that's A. Right? And then the period of the function, the period is really given by the normal amount of distance that it takes to see a sine wave. In this case, that's 2 pi, right, for a sine wave, divided by B. So that's going to be 2 pi divided by 120 pi. So the pi's cancel out, and 2 goes into 120 60 times. So 1 over 60 is the frequency. I'm sorry, the period. So in a sense, so B, when they're looking for what's the frequency, let's take a look at a couple of definitions. You'll find these in your book, or of course you could always Google it. So the period is the time, in this case, because that's our input, to see one complete cycle or one sine wave. Whereas now the frequency, F, is the number of cycles per unit of time, in this case per second. So how many cycles would we see in 1 second? Okay. So basically we've already found the period. So the frequency is the reciprocal of the period, so that's all we have to do there. So the frequency is 1 over P. In this case, the period, so 1 over 60. So that's going to be 60, right? Now, what that means is, here we see it takes 1/60th. So the interpretation on this for A, the period, how we know, what does that mean to us? It takes 1/60th of a second to see one sine wave. Whereas the frequency, it basically says that we see 60 sine waves in 1 second. So what that means is you just pick a spot and then you watch the waves go past, and you'd see 60 waves past that spot in 1 second. Okay, so that's the interpretation of A and B. So here we go over there. Okay. Now we want to graph the function on the interval 0 to 3 over 60. Right? All right, so let's take a look at that. Now, we've already got some information to help us graph. All right. We already know for part C to find the graph on 0 to 3 over 60. We already know that the amplitude is 110 and it's positive. We already know here, let's take a look back at the equation. In fact, I should probably put that up here. E equals 110 sine of 120 pi t. Right? So we know that there is no k, right? We found that, that's k is 0. We know that b is 120 pi, and c is also 0, right? All right, so what that means then is as we go to graph, we already know the period we already found in part A is 1 over 60. And then if you want to do negative c over b to find out where's the phase shift, which you could do 120 pi t equals 0, so divide both sides by 120 pi. So of course t equals 0. That's where the wave begins. Where does the wave end? So 120 pi t, where is that equal to 2 pi? Right? So that'll give you t, let's see, divide by 120 pi here. So t equals, pi's cancel out, 2 goes in there 60 times, so 1 over 60, which we know, of course, because the period we found is 1/60th. If you take the end of the wave, subtract the beginning of the wave, you just get 1 over 160 minus 0, which is 1 over 160. So we know the period is 1 over 60. So now we've got all the pieces we need. So I'm going to start. I'm not going to bother starting at anything negative, right? This is just time and the voltage. We know this is going to go from 110 to negative 110, starting at 0 here. And they want us to show 3 cycles, right? Because you have the period is 1 over 60, so I'll see 1 cycle within 1 over 60, but I want to go all the way to 3 over 60. So I really want to kind of divide this into 3 parts. So if this is where I'm going to end here, let me kind of eyeball it and try to make it pretty accurate. There you go. And now what I want to do is draw the sine wave in here. But remember, anytime you draw a sine wave, there's 4 parts to it, right? So we want to go ahead and do that. All right, so now all I have to do is apply what I know. The sine wave starts at the axis, and in this case, it's not reflected. So it's going to go all the way up to here, right? Then it's going to come down to here. It's going to go here, here, and then it's going to go back up, come here, 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 and so on and so forth, right? It just keeps repeating itself. That's the whole idea. It's very cyclical. That's why we use trig functions. So here we go, like that. All right. Oop, missed it, but should have gone through right there. Okay. And there you go. That's what you would get. Let me just show you on the calculator what that would look like. Let's see if I can get a good view here. So you would want to go to y equals, right, and turn off any plots, and then put in the equation 110 sine of 120 pi x. So the x is right there. Okay. You'd want to make sure you were in radians, because remember these numbers like 1 over 60 and time is in seconds. That's going to be in radians, it's not degrees. So you want to make sure you're in the radian mode. And then you want to make sure your windows, okay, we know we're going to start at, let's see, we're going to start at 0, and then you'd want to go to 3, well, let's go to, yeah, 3 divided by 60, right, because that's what they're asking here. That's my end value, and let me go ahead and mark that. This is 3 over 60, right, this is 1 over 60, where I see the end of one wave. Here's the end of the second wave, 2 over 60, end of the third wave, 3 over 60. Okay, so now the x scale I would probably do 1 over 60, right? See one wave. And then I want to go from like at least negative 110 to positive 110. I like to overshoot it a little so I have some space, okay? Then when you press graph, there's your graph, okay? All right, thanks so much for listening.